Hello and welcome to your next critical thinking video. This section is going to be all about rounding and estimation. Now with rounding, this should be review. And basically, I'm just going to be going over the rounding and how it works, but also show you place decimals. And I've got a chart in your notes that we'll go over, and we'll do some examples when it comes to rounding and just situations we might want to do some with. Remember with rounding that you first want to look at the digit that is to the right of the digit, right? So whatever digit you want to round, you're going to look at the digit to the right of that digit. Now, if the digit to the right is 5 or greater, then remember we round up. We add a digit. That's how we'll round. So we'll round that digit up. And then all the rest of the digits become 0. If the digit to the right is less than 5, we are not going to change the digit, and we're just going to leave it as is. But again, we're going to put zeros to the right of that number. So this is rounding. And again, mostly review. But let me just show you this chart. And this is a good chart to use, especially if you're doing your homework, because it's showing you the place values. Now, I know the ones to the left we pretty much know, right? You've got the ones, the tens, the hundreds, the thousands, and so forth. But to the right of the decimal, this is where we've got tenths, hundredths, thousandths, which these three you're probably used to. But then you keep going. It actually goes, it continues on. But for example, we've got the 100,000ths and the millionths. So we're going to be very careful when we're looking at, when you're doing your homework and it asks you to round to a certain place, be careful whether it's saying to round to your 10,000s or your 10,000ths. Very different. And you'll see it in writing. It might be easier than listening to it. Now, let's start here. What we want to do is we're going to round 7,345,464 to the nearest hundred. All right, so I'm going to take my pen, and I know that the hundreds place, right, is right here where the 6 is. That's the number we want to round. Well, then that means we need to look at the 5, which I'm circling, to know which way to round. The 5 is higher. Now, first of all, let me just go ahead and show the rest of these numbers we are not touching because we're only rounding the hundreds place. So anything to the left, we're leaving. Since we have a 5 to the right of the 6, that means we round up. So then that would become 700. So the whole number would be 7,345,700. Look at number 2. It says round 1.54578 to the nearest thousandth. All right, the thousandth place, I'm underlining it right here, is that 5. That means we're going to look at the 7. The 7 is definitely more than 5. So that means we're going to round the 5 up to a 6. So my number would be 1.546. Now, here's the thing with the right of the decimal. You could just leave this. Or if you're comfortable, if you'd rather put the zeros, you can. It's just when we already have a decimal, you technically don't need to leave zeros after anything to the right when we're working past the decimal to the right of the decimal, but you can. The next one, round this number to the nearest 100,000th. Okay, the 100,000th place is right here. I'm going to underline it, right? So here, because that's your 10,000th. So the 1 would be your 100,000th. See, I can't even say it. So I'm going to look at the number to the right of it. It's a 2. The 2 is not greater than 5, which means I'm not going to round that up. It's going to stay the way it is. So my number would be 674.34591. And again, you can leave that, or if you want to add the zeros, you can do that as well. Again, I'll leave that up to you. All right, let's go to number 4. This says that you purchased bread for $2.59, detergent for $5.17, a sandwich for $3.65, an apple for 47 cents, and coffee for $8.79. The total bill given to you was $24.67. Is this amount reasonable? Now, you could take a calculator, of course, and add this up to see if it is. But what if you don't have it on you? What if you have nothing on you? You don't want to try to sit there and add all that. What we could do is do an estimate. So let's look at how we would do that. First, I would break each thing down. And I'm going to round to the nearest whole dollar just to make this easier. Because like I said, if you did not have a calculator on you, but let's say something fell off or you weren't sure if you were charged right, then we need to write down, let's just round to the nearest dollar. So looking at the bread, which is $2.59, that's a 5. It would round to $3. That's if I'm rounding to the nearest dollar. How about detergent? $5.17, so that would round to $5. Then we had a sandwich. Oops, which I did not even spell correctly. So just ignore that. The sandwich would round to $4 because it's $3.65. Again, we're rounding to the nearest dollar for simplicity. Then we had an apple. So now this is where you want to be careful. Notice the apple. It's less than 50 cents. We're rounding to the nearest whole dollar. So we can't round to a dollar because it's not 50 cents. It's 47 cents. The nearest dollar would be $0. So that's where I'm going to round it. And then we had coffee. That would round up to $9. Now what you want to do is you want to add all of these up. In other words, what is your total? Now this you can do, right? You wouldn't technically need a calculator because you've rounded this to the nearest dollar. So when we add all these up, we get $21. Now let's go back to the bill. The bill was $24.67. Now this is not, we're not counting, this is no tax, this is the total. So that means that if my total was $21, then that tells me when it asks, is this reasonable? Then my answer is no, somewhere something was incorrect. But again, this is how you could do a quick rounding with estimation just to get an idea. Now let's look at the next problem. A carpenter who works full-time earns $28 an hour. Estimate the carpenter's weekly salary. Now, notice it says estimate. So we're just going to round. And what I mean by that is instead of $30 per hour, we want to make this quick. This again, let's just say we didn't have a calculator on us. And he works 40 hours a week. We're going to say full-time. So we would estimate $1,200 per week. Now it says to estimate the annual salary. So again, we're rounding. So what I'm going to do is round 52 weeks to 50 just to make this quick, right? Because I just want to do a quick estimate. So I'm going to take 50 times 1,200. And with that, you should get 60,000. Now again, this is just if we're rounding and doing a quick estimate. And what you could do, you could always take the 28 times 40 to see how close you are, or take the 28 times 40 and then times your 50 to see how close you were when you were just doing a quick estimate to see how much you might estimate to make. All right. Let's move up. And we're going to be looking at this chart. So you're definitely going to want your notes out because I'm going to be kind of scrolling down past. I might go back and forth, but this is a chart showing the life expectancy in the United States by year of birth. And it starts from 1950 and goes to 2020. Now, I'm going to show you here on this graph. It says we want to use the graph to estimate the following. Part A says a male's increased life expectancy, rounding to the nearest hundredth of a year for each subsequent birth year. Here's the thing, with word problems, sometimes you're going to have to read it a few times to understand what it's asking. So here's a little note I want to make. All right, let me go here. So what it's asking, okay, is to find the average yearly increase in life expectancy. That's what that is asking. We want to find the average yearly increase in life expectancy because notice it's given it to us every 10 years. This is asking us to find it every year. What has been the increase every year? Well, in that case, what we're looking at is we're going to look at the change in life expectancy from the years divided by the change in time. So we're going to look at the change in life expectancy I'm just going to abbreviate that, divided by the change in time. Now, here's the thing. Does that sound familiar to you? Talking about the change in life expectancy over the change in time. What that is that slope. So if it's been a while since you've done graphing or anything like that, that's actually what we're finding. So when we're asked to find the average yearly increase, right? So we're looking at every single year. That's technically slope. You don't even need to know that. But I just wanted to share that. Now, what we need to do then is we're going to look at two numbers. Okay, I'm going to circle them down here. We're going to look at 1950, but it's males, so we're going to look at that number. And then we're going to look at the very end. Very consistent here. We'll always look at the beginning number and then the end number. So we're going to look at 1950 and the number that corresponds with that, and then 2020 and the number that corresponds with that. All right, so keep that in mind because now I'm going to scroll down so we can write. So you're not going to see the graph in my video, but we're going to write here. What we have is we want to look at, let me just write down the 2 years. So we said we were looking at 1950, and we said that that was 65.6 years. And then we're going to look at 2020, and that was 77.1 years. Just taken from the chart. So you can look back at the chart and you'll see that that's the numbers that we had circled. So now we're going to do the formula, which I just said was the change of the change in age. So 77.1 take away 65.6 divided by the change of years. So take the latest years minus the earliest year. This is what we're calculating. So you can use your calculators. Just take the top, right, the numerator. I can put it in parentheses if you want. But you're going to take the numerator, subtract that, take the denominator, subtract that, and then divide those two numbers. It should come to about 0.16. And what this means is that a male's life expectancy is increasing by 0.16 year. Every year, the increase is by 0.16. That's the life expectancy. So every time you increased a year, we're averaging it to be about 0.16. Now, this is asking the life expectancy of a male born in 2030. That's not in our chart. That means we have to figure this out by looking at what we already calculated. Now, think about this. We're going to create a formula. Now, you don't have to know this, but I'm going to put it down anyway. If this looks familiar from the old way of when we did graphing, M was your slope. That's what we found up here. That's your 0.16. All right, and then B, well, that's what we're looking at when it comes to the beginning number, which was the 65.6. So let me just show you. You don't even have to know that formula. But if I want to create a formula, I would say y equals 0.16 times x plus, and the B is always going to be the very first year. The very first year, but the number that goes with that. So in this case, it would be 65.6. And don't worry, we'll do another problem after this just to reinforce this formula. But you always take what you found here for the average increase. You put that in front of x. The number that goes here is the very first number we have on the chart. Now, what is x? Well, in this case, we were told that we want to find the year 2030. All right, well, the year 2030, that's what we want to find. Well, what we're going to do is find out how many years that is from 1950. So I'm going to take 2030 minus 1950, and that would be 80 years.